Okay. So, looking at how we might graph this thing. First thing we want to do is find zeros in numerator and denominator. For any polynomial or rational function, you find the zeros in numerator or denominator, meaning you set each factor equal to 0. Okay? Okay. I'll say if necessary, rewrite this thing. If it's already in completely factored form, you don't have to do it, okay? Not totally necessary to do that, but look at what almost happened. Okay? If this had been x minus 2 instead of x plus 2, then you'd have had a x minus 2 squared. Okay? I changed that to cubed. I'm going to change it back to squared. I have a reason, but I think I need to do that. Okay? So there it is, completely factored. Okay, 3. Locate zeros and asymptotes, determine where the function is positive and where it's negative. So I'm going to put the y-axis here, and I haven't said locate the y-intercept. Of course, the y-intercept is going to be pretty close to 0, because when x equals 0, you got 6 times 3 is 18. Times negative 2 is negative 36, times 7 squared, that's 49, okay? And that would give you 1800 minus 36, okay? 1764. Be 1 over 1,764, which would be really close to 0, okay? Really tiny value. So we can say, okay, the y-intercept is really, really close to 0. Not closer than that, but we'll just take that, okay? Now we locate our zeros. Well, they're at x plus 2 gives you 0 at negative 2. X plus 3 gives you 0 at negative 3. I'm saying not a 0. These are going to be asymptotes because they're in the denominator, zeros of the denominator. And then we have 1 at 2. Further over. And at negative 7. And these are going to be critical asymptotes, so we might indicate that. And I've done numerous examples. Every one looks pretty much like this. Okay. Now we know that the y-intercept is negative because we're going to get, if x is 0, you get 6, 3, negative 2, and the square of 7. Everything's positive except that 2, which is negative. It's going to make it negative. So we know that the function is negative on this interval. Then, between 0 and 2, well, that's not an asymptote. All the way from negative 2 to 2, between the asymptotes. To the right of 2, well, if x is a really big positive number, all these are going to be really big positive numbers. So they're going to be positive. They're going to go positive here, which tells you how it behaves at the asymptote. At this asymptote, it's got to come down from positives, and it's got to come up, well, go down toward negative on this side, okay? It's the only way to move from point to point, okay? And testing between negative 2 and negative 3, you can test like negative 1.5. You'd have to plug in all the numbers here, okay? Or you could say, okay, if x is between negative 2 and negative 3, then x minus 2 is clearly going to be negative. X plus 2 will be negative. X plus 3 will be positive. You could check this out, but it's going to end up positive, and this will end up positive. So you're going to be positive. You've got two negatives there. So the function's going to go positive in this interval. It's going to go negative on this interval. I'm not going to go through all the details. You can check, you plug in negative 4, you can use a little numerical reasoning. And it's going to go negative here. If x is a huge negative number, x squared is going to dominate these. Those are both going to be positive. This is a square, it's going to be positive. X minus 2 is going to be negative, so everything but x minus 2 will be negative. Now that you know the sign on each interval and you know a y-intercept here, you can begin to sketch the graph. So, over here, it's fairly straightforward. Also, if x is any kind of a huge number, the denominator is going to be really huge. And when you divide that into 1, you're going to get almost 0, okay? So you determine far left and far right. You approach 0 for both. So you've got a vertical asymptote here and you approach 0, so it's going to do this. Okay, you've got a vertical asymptote here, it's going to be negative. It's going to approach 0, so it's going to do this. Negative for this whole interval, it's got an asymptote here. An asymptote here can't cross the x-axis. So it's going to come up like so. Probably going to get pretty close to the x-axis, although I won't hold you responsible for noticing that. Okay? But it's going to do this somewhere there. Okay? Positive, both of these asymptotes can't cross the axis because there are no zeros. Negative, from here to here. Asymptotes here and here passes through this point. That's a reasonable picture. Okay? Now, there's also a polynomial in the question you asked about, Anthony, but in that case, you do exactly the same thing, except some of these would be zeros, so it has to go through the axis. Okay?